In this class, we are going to look at Math 1120, question 2. And to begin with, we'll start from this question. Question says, given that the function f of x is equal to x plus 1 over 3x minus 4, and h of x is equal to x squared minus x, solve the equation which has been given there. So we see that we're being told to solve, so h of f inverse, like this, f inverse over x equal to 0. So we're told to solve this. So we already have our h, but we must find our f inverse. So to find our f inverse, we say f of x, our f of x is equal to x plus 1 over 3x minus 4. So we replace y where f of x is, and we have x plus 1 over 3x minus 4. The next step is you have to make x the subject of the formula. So here I'll just cross multiply. Then I'll have y multiplying 3x minus 4, then equal to x plus 1. When I expand this, I get 3xy, then minus 4y equal to x plus 1. Since I'm making x the subject of the formula, it means that I must bring x on one side. So I will bring this x which is at the right, to my left side, and I'll take this negative 4y to the right side. Then I'll have 3xy minus x. Then this will be equal to 4y plus 1. Then I can factor out an x here. Then I'll have 3y minus 1 equal to, this will be 4y plus 1. Then here I can divide by 3y minus 1, and I just get my x is going to be equal to 4y plus 1 over 3y minus 1. So next there, what I do is, where there is my x and y, I'll just swap my x and y. So y will come here, and where there is y, I'll put x. Have 4x plus 1 over 3x minus 1. Then where there's y, I'll replace my f inverse of x to be equal to 4x plus 1 over 3x minus 1. So here, this is my f inverse function. So from here, I must continue now to find or to solve that equation, which is h of f inverse of x equal to what? Equal to 0. So how do I continue from there? So here what I do is, this is the same as saying h there, then f inverse of what? Of x equal to 0. So it means I'll have the function h of x, and where there is x in that function, I'll replace this function, which is f inverse of x. So my h of x is this one here. So that is x squared minus x equal to 0. Then where there's x, I'll replace the inverse function of f, which I just found. So meaning I'll have 4x plus 1 over 3x minus 1, then squared minus 4x plus 1 over 3x minus 1. And this here should be equal to 0. Then I can now solve for what? Can solve for x. I can find the value of x. So that is going to give me, so I'll just take this part, the other side. So I have 4x plus 1 over 3x minus 1, like this, then squared. And this is going to just be equal, this when, because the other side becomes positive, and this will be positive 4x plus 1 over 3x minus 1, like this. Then here, what I can do now is I'm going to I can divide both sides. So here I have this 4x plus 1 over 3x minus 1 is multiplying by itself. like 2 times. So that is the same as 4x plus 1 over 3x minus 1. Then 4x plus 1 over 3x minus 1, like this. So I can divide both sides by the 4x plus 1 over 3x plus 1. Here, just remain with one of these, which is 4x plus 1 over 3x minus 1. Then the other side divides into their ones. Then here I can cross multiply. I'll just have 4x plus 1 equal to 3x minus 1. Can group the like terms. So I'll have 4x minus 3x, like this, is equal to negative 1 minus 1. And this is just going to give me x being equal to negative 2. So the value there of that equation is just going to be x equal to negative 2. Right, let's move on to the next question. So the next question, we have this question here, and it says the roots of the equation 2x squared minus 2x squared minus x plus 4 is equal to 0 are alpha and beta. Then they're telling us find the quadratic equation with integer coefficients which has the roots, and these are the other roots now, which it has. So we must find a quadratic equation corresponding to those roots. So how are we going to do this? First of all, we should note that alpha plus beta is going to be given by negative b over a, and then alpha beta is going to be given by c over a. So now, as you can check this equation, our general form of the quadratic equation is just ax squared plus bx squared plus c is equal to what? To 0. So you have your a, your b, and your c. So here, even in this question, which is there, we have 2x squared minus x plus 4. So we have our a, our b there, which is negative 1, and our c, which is 4. So we can replace there. In the first one, we have negative. So our b there is negative 1. Then divided by our a is 2. So meaning alpha plus beta is just going to be equal to half. Then here, alpha beta is going to be equal to, so c over a. What's your c? Your c is 4. And our a is 2. And this is just going to be equal to 2. So these are going to be good to take note of, even as we go on further. So let me just write it on the side. So let me erase this. Then I'll write them yet again. So my alpha plus beta is equal to 1 over 2. And my alpha beta is just equal to 2. Okay, then now they're telling us that these here are the roots of what? Of the quadratic, of a quadratic equation. What that means is when you factor out these here are what make that quadratic equation to be a 0. So as a linear factor, they can be written as x minus, so you have alpha plus beta over alpha squared, like this. And then you have x minus alpha plus beta over beta squared, and this is going to be equal to 0. So when you equate this to 0, you understand that you just have this will be positive. That will just give you, okay, for the first part, let me do that, alpha plus beta over alpha squared. If you equate this to 0, you're going to have x equal to alpha plus beta over alpha squared. So this is what you get when you equate. And of course, those are the roots which we've been given in the question. So now let us work out this. So what we do to find that quadratic equation is we're going to expand here. So when we expand, which means I'm multiplying this part with this part, then I'm going to have x multiplied by x. I'll just have x squared. Then I have this part here, negative alpha plus beta over alpha squared multiplied by x, and that just gives me negative alpha plus beta over alpha squared. x, then minus that other one is going to be alpha plus beta over beta squared, like this x. That's when I multiply this x with this alpha as beta. Then I have this other part where I'm going to multiply negative alpha beta over alpha squared minus this multiplied by the negative of this negative alpha plus beta over beta squared, and that's just going to give me, so I have alpha plus beta on top. Of course, they'll be multiplying, so that will be squared. The sign here becomes positive. Then down there, I'll just have alpha squared multiplying the beta squared. And of course, this here, we're saying equal to what? To 0. Okay, so from here, I continue. So I raise the top part here. And I'll have, when I work out this, or when I clean it up, I'm going to just have alpha minus, so I have alpha beta. So if you can see this part, and this part, they have an alpha beta, a negative. So negative, of course, in common, first of all. Then alpha and beta are common. So alpha plus beta, I mean, are common. So you have them out there. And what remains when you factor out this? So when you factor out, you just remain with 1 over beta squared. Then you have plus 1 over alpha squared. And the x, of course, is also what? Common. So the x there. Then this other part, we keep it the same. That's alpha plus beta squared over alpha squared beta squared. So you have this. Now, from here, we can further on make this part here on the mid where we have alpha over beta squared plus 1 over alpha squared into a single fraction. So raise this part. Then I'll just have x squared minus alpha plus beta, and then making this part here into single fraction, the common factor or common denominator, that's going to be alpha squared, beta squared. Then I'll just have on top, that will going to be alpha squared plus beta squared. Okay, then x plus x there. Then I have on this other side, I keep it the same. That's alpha beta squared over alpha squared, then beta squared. So I've made it into a single fraction. Now, one thing to note is uh, here on top, here we have alpha squared plus beta squared. So we have alpha squared plus beta squared. So now, how do we write this just in terms of alpha plus beta, where we just have alpha and beta? So you can note that when you have alpha plus beta squared, like this. So let's work out what alpha plus beta squared is. Okay, so alpha plus beta squared. So when I expand, this is going to be, so that's going to be alpha squared plus 2 alpha beta. Then I have plus beta squared. So here I can have alpha squared and beta squared to remain. Then I take the 2 alpha beta the other side. So I'll have alpha squared plus beta squared is equal to, then I have alpha plus beta, like that, squared minus 2 alpha beta. So it means where there's alpha squared plus beta squared, I can replace alpha plus beta squared minus 2 alpha beta. So, which is going to give me, I erase this part here. Okay, so that's just going to be alpha squared minus alpha plus beta. Then you're going to have, there I can replace now. So I replace that part with alpha plus beta squared minus 2 alpha beta. Then what is down is going to remain what? The same. Or if you can see, I can put a 2 out. So I have this written as alpha squared, beta squared. But you agree this is just the same as alpha, beta squared, because this squared can distribute to there, and to be like that. So I can write what is down as alpha, beta squared, like that. Then the x, of course, here. Then I have minus. So I have plus, of course, said plus. Then what did I have? I had alpha. I have this here, alpha plus beta squared, like this. Then over that, I can write it as well as alpha plus beta squared. And this, of course, is equal to 0. So we can now continue from there. Okay, so we have x squared. Now, at this stage, I can replace. I know what alpha plus beta is. I have there, it's half. And what alpha beta is, it's just 2. So here, negative. Then, where there's alpha plus beta, I replace 2, 1 over 2, I mean. Then there as well, 1 over 2 squared minus 2 multiplied by 2 over here 2 squared, then x plus, can replace there 1 over 2 squared over there 2 squared, and this is equal to 0. So I have x squared. So I have x squared, then I can evaluate what is inside first. So let me keep this negative 1 over 2. I can multiply the negative there. Then what is inside, I'll have 1 over 4, because when I square half, I get 1 over 4. Then multiplied, so this will be minus 2 by 2 is just going to be 4. Then divided by 2 squared is also 4. And I get this x, then plus here, when I multiply, when I square half, I just get 1 over 4. Then square 2, I just get 4, and this is equal to 0. Then I can continue working out this. Okay, so this is just going to be x squared minus 1 over 2. Then what is inside there? So when I work out 1 over 4, so I have 1 over 4, and we're saying minus 4. That's going to, then we are dividing by what? By 4. So that gives me negative. So this is going to give me negative 15 over 16, like that. Then x. Then I have that other one where I have 1 over 4, then divided by what? By 4. It just gives me, that would be plus 1 over 16 is equal to 0. Then can just multiply that negative half with what I have. So that will be x squared negative half with what's inside here. I'll just get positive. That'll be positive 15 over 32. And the x goes there. Then I have plus 1 over 16. And this here is equal to 0. So this is the quadratic equation corresponding to those roots there that are given in the question. All right. Are there any questions here? Okay. All right. So let's move on. So we go to the next question. Next question says express. First one says express the function f of x, which is that there in the form f of x a, then a x plus p squared plus q, where a, q, p are members of real numbers. So to express that, they're just telling us to complete the square. So we have f of x equal to, I can write my 3 there, 3x squared plus 12x minus 14. Then here, what I do, I factor out the negative 3, such that I have x squared. Then that there is going to give me 4x. Then I'm going to get, so divide that, I just get negative, so that will be positive, plus 14 over what? 3, like this. Then I'll have negative 3. Then here I'll bring x, half the coefficient of x there, which is 4. Half of 4 is just 2. Then I'm going to add to close that and square. Then minus. So you half and square it. So half of negative 2 is negative. Half of negative 4 is negative 2. Negative 2 squared just gives us 4. Then you have plus 1 over 3, like that. Then you can now add these, and so when you add, you have 14 over 3, then minus 4. That just gives you 2 over 3. So you have, this is going to just give you x minus 2 there. Then that will be plus 2 over 3. Then can multiply that negative 3, then you have negative 3x minus 2 squared. Then that is going to just give you negative 2. So this is negative 2. So we have expressed it in that form which we are being asked to. Okay, so next, what do we do? So it's going to be very important to, let's keep this form. That's negative 3x minus 2 squared minus 2. So this is how we've expressed. Then now, the next question says, sketch the what? The graph. We sketch the graph. And then they're telling us to clearly indicate, so we must indicate turning points and where the graph crosses the axis. So how are we going to do that? The turning points, because we've factorized by completion here, we already have them. So it's just, they're given by negative 2 over a, then 4ac minus b squared over 4a. So this is how it's given. And this part here is just this one. So we just have to multiply it by the negative there. So that will give us positive 2. And then the other part is, this part is that one. And that just gives you negative 2 there. So this here is your turning point. Turning point is just 2 comma negative 2. So turning point just 2 comma negative 2. Then the next thing that we must check is, do we have a y-intercept? Of course, y-intercept is just the point where x is what is 0. So replacing 0, that this function which is given, replace 0 where x is there, and you just remain with negative 14. So our y-intercept is negative 14. Then you have to solve for the x-intercepts to see where the graph is going to cut the x-axis. So you have x minus 2 squared, then minus 2, like this. You just have to equate this to 0. Then you have negative 3. Then x minus 2 squared is equal to, so 2 goes the other side, and you're going to, here you can divide by this negative 3, and you just get x minus 2 squared equal to negative 2 over 3. Reduce the square root both ends like this, and you just have x minus 2 is going to be equal to, okay, so there, as you can see, we have we have this negative here. So because of that negative there, that negative is just telling us that we're going to have a complex, we're going to have an imaginary root there. Because when we say root of 2 over 3, this we're saying it's multiplying by the negative 1, but I can now separate this as that negative 1. And this is just going to be root 2 over 3, then the negative 1 I can represent by I. So when I take 2 the other side to be 2 plus, I have this here, 2 over 3, and then I. So this is an intercept. So when you have an imaginary x-intercept or intercepts, then it means that it means that it means that the graph is not going to cut at any point on the x-axis, meaning that graph is not cutting the x-axis. So meaning we have already what we need. We have all the intersecting points, which is going to be the y-intercept and those turning points there. So you can draw your axis like that. Okay, so you have your x there and you have your y. Then, so here you identify, you said our turning point is 2, comma, -2. So if our 2 is here and our -2 is there, so this here is going to be our turning point. This is where the graph is going to turn from. Then going down here, let's say our -14 is here, -14, and we have our -2. So our graph is passing through at 14 when y is equal to what, -14. Then it's turning here, so meaning this is where the graph is turning from, and of course it's connecting like that. Then this other side is going to go like that. All right, so this is how the graph is going to look. Already you had a negative in front of this here. So when you have a negative, we had negative x squared plus 12x minus 14. So when you have a negative here, when the value of a is less than 0, then you know that your graph is going to be turning downwards, and you have a maximum turning point like you see in the graph. And of course, you can label this as f of x is equal to 12x minus 14 minus 3x squared. So this here is the graph. All right. Next question. The next question says, given that x plus 3 is a factor of the cubic function, which is this one here, h of x, where I have x cubed plus, okay, that. And h of x gives a remainder of 10 when divided by what? By x minus 2. Find the value of a and b. So they've told us, first of all, that x plus 3 is a factor of this function here, the function which is h of x as x cubed plus ax squared minus 2x plus b. So if x plus 3 is a factor of this equation, so equating this to x, and this gives us -3. It means when we plug in -3 into this function here, where x is, of course, then this here is going to be equal to 0. It's going to give us what? It's going to be equal to 0 because this is a factor. And if it's a factor, meaning it's a 0 of this polynomial. So I can replace there my -3, and I'll just say -3 cubed, then plus a, -3 squared minus 2, -3 plus b. So we are saying this here is going to be equal to 0. So when we cube this first part, that's going to be -27. Then we have that's going to be square 3 by 3. -3 by 3 gives us 9. That would be plus 9a. Then the negative there by the negative gives us plus 6 here. Then we have plus b. And this here we're saying should be equal to 0 because they've told us it's a factor of this polynomial. Then the next thing now is you're going to group here. I can add this and I just get -21. Then that is going to be plus 9a, then plus b is equal to 0. Then from here I can write this function in terms of what? Of b. So I'll say make b the subject, then that will be 21, goes the other way, then I'll have minus 9a. So I've written it just in form of b, and I'll keep that equation here to say b is equal to 21 minus 9a. The next step is I will follow the other statement which has been given. So the other statement is, in this same function, when it's divided by x minus 3, it leaves a remainder of 2. So h of x, like this, x cubed plus ax squared minus 2x plus b. So here, x minus 2, like this, equal to what? To 0, and you have x to be equal to what? To 2. So I replace where 2 is, and then 2 cubed plus a 2 squared minus 2 multiplied by 2 plus b. Then this is just going to be, okay, here when I cube this, I just have 8. Then square this, I have 4. That would be 4a. Then that would be minus 4 plus b. And they're telling us when it is what? Divided by that, it's going to give us a remainder of what? Of 10. So this here is going to be equal to 10. So now we can add these two parts. I can add them, and I just get 4 plus 4a, then plus b is equal to 10. Can make this equation, I can make b the subject of the equation, and I'll just have, so when 4 goes the other way, it becomes negative 4, so it will subtract with a 10, and that gives me 6. Then I have minus 4a. When that, the 4a goes the other side. So I'll have this here. So I have these two equations. So meaning I can now equate these two equations to each other. So when I equate the equations, so I have b there and I have what? I have b there. So I can just equate them. So that will be 21 minus 9a equal to 6 minus 4a, like that. Then having this here, I can make so I'll let the 21 go the other side, and I'll bring the 4a this side, so that will be plus 4a. Then I'll have 6 minus 21. This here is going to give me negative 5a, and this other side gives me negative 15. Dividing by 5 there and by 5 there, negative 5, I mean both sides, I'm just going to have a equal to 3. So the a value is equal to 3. Then I can get this equation or the other one and just replace where a is. I'll use the one down. So b is going to be equal to 6 minus 4. Where there's a, I put the 3, and I'll have b is equal to 6 minus 12. And this is going to just give me b equal to negative 6. So therefore my a is 3 and my b is negative 6. All right, this is how you handle this question. Next, we have this question here. Should be the last question that we are looking at. And it says factorize this cubic function. So to factorize this cubic function, what we must remember is by the factor theorem here, I can say, so I'll let me write, so I have this function, of course, start by writing negative x cubed minus 7x squared minus 4x plus 4. So I'm saying I'll let my a be equal to negative 2 and my b be equal to 4. So when we say to find the factors of this, I'll be saying possible factors, which I can, let me just go f, then these will be given by all the factors of b, the negative positive, divided by negative positive, or factors of what? Of a. So the factors there of the first one, so that is 4, both are saying negative and positive. So you have 4, then the other number that divides there without giving a remainder, you have 2 to be a factor, and also you have 1 to be a factor. Then down there, just going to have plus minus 2 of a, that's plus minus that, and also plus minus 1. So now here you have to look for a factor where, let's say, okay, when I get 4, positive 4 divided by 2, I get what? 2. So I test this 2, I'll replace it in this where x is. Then I want it to give me what I want. If this equation gives me a 0, or if this function is going to be equal to 0, then 2 is a what? Is a factor of this polynomial. So let's say I had I had positive 2 on top, positive 2, then divided by negative 1, and this gives me negative 2. So I'll test negative 2. So if negative 2 here, I place negative 2, I have negative 2, then negative 2 uh, there, cubed, then minus 7, negative 2 squared, minus 4 multiplied by negative 2, then plus 4. So I can work out this. This will be negative 2. Negative 2 cubed is negative 8. Then 7, negative 2 squared is just 4. Then I have minus 4 here multiplied by negative 2 plus 4. Okay, so this here is going to give me, I continue with this, I'm just going to get, so you're going to get, multiply the negative and that's there, you get a positive 16. Then when you multiply the negative 7 and 4, that just gives you negative 28. Multiply this and that, there you get positive 8. Then you have 4. So adding 4 plus 8 gives us 12, then plus 16 gives us 28. So I'll just have 28 minus 28, which is going to give me 0, which means x equal to negative 2 is a what? Is a this is a factor. So meaning the linear factor, taking x the other side, is going to be x plus 2, like this, x plus 2. So this is going to be the linear factor. So how do I work out from there? From there, what I'm going to do is I'll use synthetic division. First of all, I'll say I'm dividing, that factor is negative 2. Then I get the coefficients uh, of each term there. So I have 4, 3, negative 7, and negative 2. So I'll arrange them from starting from negative 2 there, then negative 7, negative 4, and 4. So I drop the 2 here, negative 2. Negative 2 multiplied by this 2 here, I just get a positive 4. I can add here negative 7 and 4, I get negative 3. Then this negative 3, I multiply by the negative 2, I'll just get positive 6. Add the 2, I'll just get 2. 2 multiplied by that negative 2, I'll get negative 4. And this here gives me 0. So this last value here is the remainder. So the remainder is just equal to what? To 0. Then here I've reduced the what? The degree of the polynomial. So it has moved from the degree of 3 to what? To the degree of 2. Because I was dividing by a linear factor which had just a variable x. So writing this here, I'll have negative 2x squared, then minus 3x, then that there is going to be my c, that will be plus 2, and this here equal to 0. The next step now is I'm going to factor out this, because of course the question is saying factorize this completely. So to factor out this, okay, to factor out this, I'm going to have, just going to say, I'll complete the square on this one. So I'll have 2, negative 2, like that. Then I'll have x squared. Then there I'll just going to get plus 3 over 2. Then x. Then I'll have minus here. When I divide by negative 2, when I divide this 2 by negative 2, I have minus 1. And this equal to what? To 0. So can continue from there. So that is going to give me, I have negative 2 there. Then inside, I'm going to have x. I have this part. Then that's going to be plus 3 over 4. Then squared. Then minus. So the half that I have, I must square it. So when I square this, I just get 9 over 4. So I get 9 over 4. Okay, no, when I square, so half of this is 1 over 4. So yeah, here 4, when I square the 4 there down, I must be getting a 16. So yes, so this has to be 16 here. Then minus 1 go to 0. So From there, I can now say negative 2, then x plus 3 over 4 squared. Here, putting this into a single fraction, I just have negative 25 over what? 16. So this is what I get, and this here saying equal to 0. Then can continue, I can now multiply my 2. I'll have 2 there, x plus 3, 4 squared. Then I'll have positive 25 over 8 is equal to 0. Then from here, we will just say negative. So be negative. So this part can go the other side. Then I'll have x plus 3 over 4 squared is going to be equal to negative 25 over 8. Dividing by 2 both sides. Can divide by 2 on both sides. So dividing by 2 on both sides, I just have x plus 3 over 4 squared is equal to, that's going to give me 25 over 16. Then I can introduce the square root here, introduce it there. Then I have x plus 3 over 4, and this is going to be plus minus. That would be 5 over 4. Then x is going to be equal to negative 4, then plus minus 5 over 4. Then this here is just going to solve and work out that my x is going to be equal to 1 over 2, and the other value is going to be x equal to,
Where did the 25 come from?
where did there?
25.
Okay, so this part here, where we say 9, negative 9 over 16 minus 1, right? So here, when we make this into a single fraction, we have 16 there, 16 to 16, 1, then you have negative 9. 1 into 16, that is 16. 16 multiplied by negative 9, I have negative 16. So I add this negative 9 and 16, and I'll have negative 25 over 16. Are you clear? Is that clear? Hello? Okay, so I don't know if they've stepped out, but yeah.
Yes, sir, it's clear.
All right, all right. So now we continue from there. So we're saying x here, the other x value here is just going to be negative what? Negative 2. So I have this part, negative 2 and negative x. So it means that my linear factors are going to be written as so that is going to be, so the one with the half, x equal to half, that's going to be x minus 1 over 2, like this. Then the other one is going to be x plus 2. Then I already found the first one as well to be x plus 2. So this here, I have factored it completely as they asked me to do in the question. So that's how you factorize. And this marks the end of this class. I don't know if there are any questions.
No questions. I'm fine.